In problem 2, we're going to be using congruent parts. In your textbook, you have a nice picture of the SR-71 Blackbird aircraft wings with some nice triangles put on there. Since I'm not much of an artist, I'm just going to take these two triangles that you see here to the right off that drawing, relabel the vertices, and this is what you're going to get. Now these two triangles to the right that you see suggest congruency. We have triangles ITR and triangle ECA. And we need to figure out what the measure of this angle right here is. Measure of angle E. The first thing that we're going to do is we're going to need to develop a plan to figure out what the measure of this angle is. Angle E. We know two angle measures in triangle ITR. We know that this measure of angle T is 30 and the measure of angle R is 75. In these congruent triangles, we also know that angle E corresponds to angle I. So we know that angle E is congruent to angle I. So we need to find the measure of angle E by first finding the measure of angle I. Using the triangle angle sum theorem, we're going to write an equation involving the measure of angle I. So we know that the measure of angle I plus 30 plus 75 equals 180. Now that we have an equation for the measure of angle I, all we have to do is solve for the measure of angle I. So we add 30 plus 75 to get 105, and we subtract that from both sides of the equation to end up with the measure of angle I equals 75. Since we know that angle I and angle E are corresponding parts of congruent triangles, we can now say that angle I is congruent to angle E. And using the definition of congruence, we can say that the measure of angle I equals the measure of angle E. Since we know the measure of angle I to be 75, then we can say that the measure of angle E equals 75. This problem deals with finding congruent triangles. The problem asks us if these two triangles are congruent, and of course we need to justify our answer, so we're going to be writing a small proof. But first, how are we going to determine whether these two triangles are congruent? First, we're going to compare each pair of corresponding parts. If all 6 pairs are congruent, then the triangles are congruent. So we're going to be looking at the sides of all the triangles, all these ones over here too, and the angle measures. And we can see some congruence markings through here too. So let's take a look at this. Okay, I've moved this up a little bit, and I've also included the steps so that you can actually see what's going on here. So as mentioned before, we have triangle ABC and triangle EDC. And we're trying to prove that these two triangles are congruent. So let's first look at segment AB, which is congruent to segment ED. We know that because it is given by these congruent markings right here. We also know that segment BC is congruent to segment DC. We know that because it's given here as well that the distance from B to C equals 4. And the distance from D to C is 4 as well. We also know that segment AC is congruent to segment EC because we are also given the distances from AC, which is 6, and the distance from E to C, which is 6 as well. We also have another 2 pairs of congruent markings here. One pair tells us that angle A is congruent to angle E, and that angle B, with these double congruence markings right here, is congruent to angle D, with these 2 double congruent markings. And right here we have a pair of vertical angles. Because the vertical angles are congruent using the vertical angles theorem, we know that angle BCA is congruent to angle DCE. So now we know we've just proven that all 6 parts of these triangles are congruent. So by the definition of congruent triangles, we can safely say that triangle BCA is congruent to triangle DCE.